This is the part 8 of mathematical physics. In this video, we discuss about complex number system. Complex number system is a natural extension of real number system, and their form is this: a plus iota b. Here this is real part and iota b is imaginary part. Let's say this is z. If we need to find their complex conjugate, then change the sign of imaginary term only. This is a complex conjugate. Here iota square is equals to -1. So iota is equals to root of -1. Now modulus or absolute of z is equals to this: root of a square plus b square, or mod of a plus iota b. Some important property of this modulus: if z1 into z2, mod is equals to mod of z1 into mod of z2. Another property: mod of z1 divided by z2 is equals to mod of z1 divided by mod of z2. If z2 mod of z2 does not equals to 0. Another property: z1 plus z2 mod is less than equals to mod of z1 plus mod of z2. Fourth property: mod of z1 minus z2 is greater than equals to z1 minus mod of z2. Now geometrical interpretation of complex number. Here this is a complex plane, or we can say Argand diagram. For geometrical interpretation of x plus iota y or a plus iota b may be written as an order pair x comma y or a comma b, and represented as a point in xy plane, in this plane, and this is Argand diagram or complex plane. Here you can see this is point P and this is their coordinate x and y, and this is angle theta, and this is distance r. So here x equals to r cos theta, y is equals to r sin theta. So z is equals to x plus iota y. Now putting this value, or we can write this. Here this is e raised to power iota theta. So we can write here z equals to r e raised to power iota theta. For z raised to power n, we can write this. And using De Moivre's theorem, we can write here cos n theta plus iota sine n theta, or we can write here this. If we multiply e raised to power iota alpha with z, we can write here this, or we can write here this. Let's do a question on complex number using binomial expansion also and De Moivre's theorem. We need to prove that cos 5 theta is equals to 16 cos raised to power 5 minus 20 cos theta raised to power 3 plus 5 cos theta. Now using this, cos theta plus iota sin theta equals to e raised to power iota theta. For if we take here e raised to power 5 iota theta, we can write here this, or we can write here cos 5 theta plus iota sin 5 theta. But using this, we didn't get this value. Now using here binomial expansion plus 5c1 cos theta raised to power 4 iota sin theta plus 5c2 cos cube theta iota sin square theta plus 5c3 cos square theta iota cube sin cube theta plus 5c4 cos theta sin raised to iota raised to power 4 sin raised to power 4 theta plus 5 c5 iota raised to power 5 sin raised to power 5 theta. Here now solving this, here 5c1 is equals to 5 plus 5 factorial 5 divided by 2 factorial 5 minus 2 is 3 factorial, and here we can write here is 10 cos cube theta. Here this is iota square, so we can write here minus sin square theta. Now here again there is iota cube, so we can write here minus iota, and on solving 5c3 we get 10 cos square theta sin cube theta plus on solving 5c4 and solving we get 5, and on solving iota raised to power 4 we get here plus 1. So we can write here this plus 5c5 is equals to 1, and iota raised to power 5 become minus iota sine raised to power 5 theta. Now here you can see here, if we use here De Moivre's theorem, this term become cos 5 theta plus iota sine 5 theta. So we can write here in place of e raised to power 5 iota theta, cos 5 theta plus iota sine 5 theta, which is equals to this term. Then comparing real part of this part, so cos 5 theta is equals to cos raised to power 5 theta minus 10 cos cube theta sine square theta plus 5 cos theta sine raised to power 4 theta. This is sine raised to power 4 theta. Now using here cos square theta equals to 1 minus sine square theta, so we can write here this plus 5 cos theta into 1 minus cos square theta whole square plus 10 cos cube 5 cos raised to power 5 theta plus 5 cos theta plus 5 cos raised to power 5 theta minus 10 cos cube theta. Now solving this, here this is cos raised to power 5 term and this also, so combine we get here 16 cos raised to power 5 theta minus, and these terms are same, so we can write here 20 cos cube theta plus 5 cos theta, and this is equals to cos 5 theta, hence proved. Let's do another question. In this question we need to prove that 1 plus omega square equals to, we need to prove here 1 minus omega raised to power 6 is equals to minus 27, square is equals to minus 27, and also find the cube root of unity, cube roots of the unity. So we can write here z cube is equals to cos 0 plus iota sine 0, or we can write here cos 0 plus iota sine 0 whole raised to power 1 by 3, or we can write here cos 2n pi plus iota sine 2n pi or using here De Moivre's theorem, we can write here this here put n equals to 0, 1 and 2 because there is z cube, so there are 3 roots. So putting z equals to 0, get z equals to 1. For n equals to 1, we get here cos 2 pi by 3 plus iota sine 2 pi by 3, or we can write this term as this, or let's say this term is omega. Second, for putting value of n equals to 2, z2 equals to this. Or we can write here in exponential form this, and here you can see this is equals to omega square. Here in this question we use 1 plus omega square, which is equals to 0. So sorry, this is not equal to 0. Let's find the value of 1 plus omega square. Here this is cos 2 pi by 3, or we can write this pi minus pi by 3 plus iota sine pi minus pi by 3 and plus omega square value, which is cos 4 pi by 3, or we can write here pi plus pi by 3 and plus iota sine pi plus pi by 3. Now cos pi minus pi by 3 is equals to minus cos pi by 3 plus pi minus pi by 3 of sine is equals to iota sine pi by 3 minus, and this term become minus cos pi by 3 minus, because this term goes in third quadrant, so in the third quadrant this become minus, so we can write here this. So this term is cancelled out by this term, so we can write here 1 minus 2 cos pi by 3. Here cos pi by 3 is 1 by 2, so this become this equals to 0. Hence 1 plus omega square equals to 0. So let's take 1 plus omega square is equals to minus omega. So let's here in the given question, this is given 1 minus omega whole square is equals to minus 27. So let's take here 1 minus omega raised to power whole 6 is equals to, or we can write here this like that, and on solving this we get here this value. Let here put the value of omega square using this equation. Here omega square is equals to minus 1 minus omega so this will equals to minus 3 omega whole cube equals to minus 27 omega cube. 1 minus omega 1 minus omega whole power 6, and if we take here cube root both side, we get this. Here omega is the root of z. Let's do another question. In this question we need to find all roots of this given equation. Let omega be a fifth root of unity. So z raised to power 5 equals to 1. So we can write here z raised to power 5 is equals to 1 plus z divided by 1 minus z whole power 5 equals to 1. So 1 plus z divided by 1 minus z equals to 1 raised to power 1 by 5, and which is equals to omega, as we let omega is a fifth root of unity. So z is equals to omega minus 1 omega plus 1. Here we use here component and dividend rule. If omega is equals to e raised to power 2 pi by 5 iota, here you can see z is equals to 1, so we can write here cos n pi plus iota sin n pi whole power 1 by 5. So this become cos n pi by 5 plus iota sin n pi by 5. For n equals to 1, this equation becomes e raised to power 2 pi by 5 iota. Here one root is 1. Sorry, if we put here n equals to 2, this become e raised to power 4 pi iota by 5, and for n equals to 3, e raised to power for this is 2 n pi, and this is iota sin 2 n pi. So this become this. For putting the value of n equals to 1, we get this, and let this is maybe this is omega, which is any one of the 5 root. So let this omega. So for n equals to 2, one root become e raised to power 4 iota by 5, and for n equals to 3, one root become 6 pi by 5, iota, and for n equals to 4, 1 roots become 8 pi by 5 iota, sorry 16, so this is 8. So you can see this is like this omega square, and this is equals to omega cube, and this is equals to omega raised to power 4. So z is equals to 0 comma omega minus 1 divided by omega plus 1, omega square minus 1 divided by omega square plus 1, and divided by omega raised to power 4 plus 1. Let's do another question. Z equals to 6 e raised to power pi by 3 iota. Here we need to find mod of e raised to power iota z. Here in this condition you can see this is given e raised to power iota z. So put here the value of z. We can write here using this cos pi by 3 plus iota sine pi by 3, and this become 1 by 2 plus iota root 3 by 2, or we can write here this iota 3 plus iota 3 root 3, or we can write here this. Now in the question given mod of e raised to power iota z, so taking here mod of e raised to power iota z, we get here e raised to power minus 3 root 3. Here this is a property of a complex number. If we take mod of e raised to power z equals to e raised to power real part of z, here in this the real part is minus 3 root 3. Let's do another question. Find the value of iota raised to power iota. Here we can write here iota is equals to cos pi by 2 plus iota sine pi by 2 whole power iota. So we can write this term as e raised to power iota pi by 2 and whole power I. So this I go multiply by this I, so this become minus pi by 2, and this is the value of iota raised to power iota. Let's do another question. If z1 and z2 and z3 represent vertices of equilateral triangle, then prove that z1 square plus z2 square plus z3 square equals to z1 z2 plus z2 z3 plus z3 z1. And this is a diagram of this given condition. For proving this, we assume the triangle is centered at origin. Each vertex is rotated by 2 pi by 3 with respect to previous one. So for value of z1 we can write here r into e raised to power iota theta if every vertex is rotated by 2 pi by 3 with respect to previous one, then z2 becomes r into e raised to power iota theta plus 2 pi by 3. And if now z3 become r into e raised to power iota theta plus 4 pi by 3, because we need here homogeneity, that's why we take here 4 pi by 3. Now finding the value of LHS, so we get here r square e raised to power 2 iota theta plus r square e raised to power 2 iota theta plus 2 pi by 3 plus r square e raised to power 2 iota theta plus 4 pi by 3. Now let's take RHS. Here z1 z2 plus z2 z3 plus z3 z1. Here z1 is r into e raised to power iota theta and z2 is r into e raised to power iota theta plus 2 pi by 3 plus z2 into z3 is r into e raised to power iota theta plus 4 pi by 3 plus r into e raised to power iota theta plus 4 pi by 3 into r raised to e raised to power iota theta. Here we get here on solving this we get here this value. Here LHS is equal to RHS. Now properties of complex function. First is analyticity. A function is analytic or homomorphic if it's differentiable at every point in its domain. At every point in its domain. Second is cauchy riemann equation. If f of z is equals to uxy plus iota v xy to be analytic, real and imaginary part u and v, this u and v must satisfy this del u over del x, del v over del y and del u over del y equals to minus del v over del x. Now third property is contour integral. In this property we discuss about Cauchy's integral theorem. Now analytic function is said to a function is said to be analytic at a point z0 if f is differentiable, fz is differentiable not only at z naught but at every point of some neighborhood of z naught. Here an analytic function is also known as homomorphic and another name is regular or monogenic. Now let's talk about Cauchy Riemann equation. Theorem: the necessary condition for a function fz equals to u plus iota v to be analytic at all point in a region R. First is del u over del x equals to del v over del y, and second condition is del u over del y equals to minus del v over del x. Provided del u over del x, del u over del y, del v over del x, del v over del y exist. Another theorem for necessary like this condition also. These are the required condition for this theorem, and also del u over del x, del u over del y, del v over del x, del v over del y are continuous function of of x and y in a region R. So f dash z equals to del u over del x plus iota del v over del x, and f dash z equals to del v over del y minus iota del u over del y.